Okay, first of all, please subscribe my channel and please watch this video and all other my videos online, and please do not download it. In the continuation of the lecture, let me try to show you when we want to in fact interpolate some points with the equal difference between two points. Before that, let me define something. I have a definition here. I want to define one thing. Okay, the first definition. Let Pn n equal to 0 to infinity is given or be given. We call the forward difference the forward difference. We show it by delta Pn, defined as delta Pn equal to Pn plus 1 minus Pn for all n greater than or equal to 0. And for k greater than 1, we define delta k Pn to form as delta k Pn equal to delta k minus 1 delta Pn, and we write this as delta k minus 1 Pn plus 1 minus Pn, and this will be delta k minus 1 Pn plus 1 minus delta k minus 1 Pn. In fact, this is a recursive definition for the forward difference, and we know that delta k or delta is a linear operator, so it can pass through the parentheses and act over each of these two terms. Okay, so in this case, if we want to construct a table for the forward differences, we can do it easily. Let me write here the table of forward difference. Let me have a table like this. For example, x0, or let me write the first column as x, and here let me have x0, x1, x2, x3, x4, and so on. And also let me have something like f of x here. Okay, so let me have f0, f1, f2, f3, f4. These are 5 nodal points. So now I can construct delta f. Okay, I compute f1 minus f0 and I call it delta f0. It is f1 minus f0. From these two I get delta f1, and this will be f2 minus f1. From these two I get delta f2, and this will be f3 minus f2, and also delta f3, it will be f4 minus f3. This is the forward difference of order 1. Now I can compute delta squared, okay, f, and for example delta squared f0, it will be delta, let me write a little better, from this one and this one. Here I get delta squared f0, it will be delta f1 minus delta f0, and here from these two I get delta squared f1, from here I get delta squared f2. This is the second column, okay? And now I can continue in the same way. From these two I can get delta 3 f0, and from these two I can get delta 3 f1, okay? And in the same way I continue delta 4, from these two I get delta 4 f0, okay? Now you can see that here I have delta f0, delta f0, delta squared f0, delta 3 f0, delta 4 f0, and so on. Now I want to use in fact this property and this kind of sequences for computing the, in fact, interpolating polynomial. Let me write a theorem here and I will prove it. Suppose that x0, x1, x2 and xn are n plus 1 n plus 1 points, n plus 1 points with equal distance. What does it mean? It means that x, for example, 1 minus x0 should be, for example, h. x1, x2 minus x1 should be equal to h, and so on for every xk plus 1 minus xk, it should be h for all k equal to 0 to n. Okay, this is the meaning of the equal distance. Now, so let me just keep it as a comment here. Okay, now I say if we define x equal to x0 plus sh, then P of s is equal to sigma k equal to 0 to n, the combination of k of s delta k f of x0. Here we know that combination k of s is s factorial over k factorial times s minus k factorial. Okay, we have this one. I want to prove this theorem, and then I want to use this theorem, in fact, to finding the interpolating polynomial. For the proof, let me suppose that let I be greater or equal than 0 and less or equal than n minus 1. Okay, so we get x minus x0 equal to x0 plus sh, because I suppose it here, minus, and let me do some change here. I put 0 I instead, 0 minus, okay, x0 plus I h. Why this is true? Because we know that all the points are equal distance. So I can write xi as x0 plus ih. So this will be true. Okay, so if you compute this one, x0 with x0 will be cancelled, and if we factor h, I will get s times s minus I times h. Okay, now you consider fx0 and x1. This will be by the definition of divided difference, f of x1 minus f of x0 over x1 minus x0. Okay, so if you compute this one, you will get x1 minus x0 is h, so I will get 1 over h, and this one is f1 minus f0. Okay, so this is f1 minus f0, and by the definition of the forward difference, it will be delta f0. Okay, so I get 1 over h delta f over 0, delta f0. Now let me do some more computation and to find something more. Let me compute f of x0, x1 and x2. By the definition of the divided difference, it will be f of x1, x2 minus f of x0 and x1 over x2 minus x0. Okay, here I know that this is x2 minus x0 by the definition, because of the equal distance points. It will be x0 plus 2h minus x0, and it will be 1 over 2h. So I can just write 1 over 2h. Okay, and now I write the definition of this one and this one in divided difference form. So I will get f of x2 minus f of x1 over x2 minus x1 minus f of x1 minus f of x0 over x1 minus x0. And now let me continue the computation. It will be 1 over 2h, and here consider this one is h and this one will be h. Okay, so I can factor 1 over h from both these terms in the bracket, and I can write f of x2 minus f of x1 minus f of x1 minus f of x0, and it will be 1 over 2h squared. Okay, and we know from the previous lecture that this is the definition of delta squared f of x0, or in fact I can write 1 over 2h squared delta squared f0. So this is true. This one is equal to this one. This will work, and it's completely true. In the general form, we can show that by induction. F of x0, x1 to xk is equal to 1 over k factorial h k delta k f of x0. This is true. Okay? We will prove it a little later. Now, consider the Newton polynomial. Okay? Consider p of x. Okay? Now, if you consider p of x equal to p of x0 plus sh. Okay, it will be f of x0 by the definition of the Newton polynomial times f of x0, x1, x minus x0 plus f of x0, x1, x2 times x minus x0 times x minus x1, and we continue in the same manner. Finally, we will get, it will be f of x0 to xn times x minus x0 times x minus xn minus 1. Correct? Now, you can use f of x0, x1 and so on from this formula and put, for example, for f of x0, x1, 1 over 1 factorial h1 delta 1 f of x0. Right? You can do exactly like this. Let me continue and compute something. And also you can use, for example, for this one, instead of x minus x0, by here, if you put x equal to x0 plus sh, and you, for example, here put x0 plus sh minus x0, so it will be sh. Okay, so this one will be sh and this one will be s minus 1 times h. Okay, and you can do for all of these in the same way. So this one, for example, is s minus n plus 1 times h, and for the other part also we have something similar. Okay, and this is the first term, and the other one is, for example, this one is 1 over h delta f of x0, or for example here is 1 over 2h squared delta 2 f of x0, and this one is exactly this is in fact 1 over n factorial h to power of n delta n f of x0. Now let me apply these changes in the formula to get something new. So let me write, this is equal, let me write f of x0 itself, no different. Here, instead of this one, put 1 over h plus 1 over h delta f of x0, and instead this one put sh. For here, let me put 1 over 2h squared delta squared f of x0 times sh s minus 1 h. So it will be s times s minus 1 h squared. And let me continue in the same manner to get for this one 1 over n factorial h to power of n delta n f of x0, and here I will get s times s minus 1 times s minus n plus 1, and I have n h that multiplied by each other, so I will get h squared. Now look at here, I can cancel h with this h squared by this h squared, and hn by this hn. Correct? I will get something like this. Now let me write this equation by sum. I can write sum k equal to 0 to n, okay, s times s minus 1 times s minus k plus 1 times 1 over k factorial delta k f of x0. Okay, so I have something like this. Now let me borrow something from discrete mathematics. In discrete mathematics, we saw that the combination k of s is equal to s factorial over k factorial times s minus k factorial. And let me write s times s minus 1, s minus k plus 1, s minus k factorial over k factorial times s minus k factorial. If you cancel this term with this term, it will be s times s minus 1 to s minus k plus 1 over k factorial, and this appears exactly here. Okay, so I can write it equal to sum k equal to 0 to n k of s delta k f of x0. But there is one thing very important that is you cannot use this combination for the real number, for the non-integer number, but we just use the sign of the combination here, and we don't use nothing more, just the notation. Okay, so this is the proof, and in fact I could find p of s by this formula. Now let me apply this theorem to solve and find an interpolating polynomial with equal distance. Let me write an example and try to solve it. Suppose that I have a table like this. I want to find the, in fact, interpolating polynomial. Let me write the problem. Find the interpolating polynomial for the following nodal points. Okay, let me write the nodal points here. Let me write xi point Okay. xi fi. Let me have the nodal point like this: 0, 0, 2, 0, 4, 0, 6, 0, 8. And let me have for fi 0, 0.199 and 0.389, 0.565, 0.717. Okay, this is fi. Now, let me write delta fi. For example, delta f0. From this one, these two, I can get 0.199. I subtract this one from this one to get 0.190. This one will get 0.176, and this two gives 1.2. So I get these terms. Okay, now let me write the other one, delta squared fi. From these two I get 0.009. From these two I will get 0, in fact it will be minus, and minus 0.014, and from these two I will get minus 0.024. The other one, delta 3 fi, this one and this one will get minus 0.005. This one minus this one minus this one. This one minus this one will give minus 0.010. And finally, in the last column, I will get this one minus this one, minus 0.005. Okay, this is the finite difference, the forward difference table for these nodal points. Now, let me compute the P of S here. Let me write now, since x0 equal to 0, h equal to 0.2, h, in fact, to finding h, you have to subtract this and this to get to 0.2. Okay, 0.2. So, let, for example, x will be equal to 1 point, be it 0.3. 0.3. I want to find, in fact, P of x. Okay? If we want to find P of 0.3, we have, okay, now let me write x equal to x0 plus sh, and from this I can get s equal to x minus x0 over h, and this will be 0.3 minus 0 over h is 0.2, and this will be 1.5. Now, let me use this one, P of S equal to sum k equal to 0 to 4, because we have 5 nodal points, okay, and we write S combination k of S delta k f of x0, and this will be k equal to 0 to 4, okay, k, and S is 1.5 delta k f of x0. Okay, now let me write this one in fact, here I can get, for example, p of p of 0 point, no, f of 0.3, and let me fix something here. In fact, we don't want to compute this one. We want to compute f of 0.3. So first of all, I have to change x to s. So here I will get p of 1.5, and this will be this one, in fact. Okay, let me extend the summation. So I will get 1.0, this 0 from 1.0 delta 0 f of x 0, okay, plus 1 of 1.5 delta f of x 0, and we continue in the same way, delta squared f of x 0 plus 3 of 1.3 delta third f of x 0, and finally I will get this one, delta 4 f of x 0. And I know f of x 0 in all of these points, x 0 is 0, okay, 0, 0, 0, 0, 0. And also I know that the combination in the discrete mathematics, it doesn't work for the non-integer number, but I told you I just use that the notation of this combination, in fact. So I can find something like this. For example, for this one, for 1.5 of 0, I use combination k of s equal to s times s minus 1 times s minus k plus 1 over k factorial. Okay, so in this way, when, for example, I want to compute, for example, this one, 0 of 1.5, I should just write 1.5, okay, and there is nothing to multiply, because I have to go until I arrive to s minus k plus 1, and here k is in fact 0, so it just 1.5, okay. Or for example, for 1 of 1.5, it will be 1.5 times 1.5 minus 1 over 2 factorial, and it's all. Okay, and in the same way, for example, for 2, I can write this one to this form, 1.5 times 1.5 minus 1 times 1.5 minus 2 over 3 factorial, and so on. Okay, so if we compute all of this term in this manner, and finally I put all in p of 1.5 to form 0 plus 1.5 times 1.199, and this term comes from here. In fact, the head of the column of the first forward difference, and the other one will come from here, the other one will come from here, and the other one will come from here, and the first one was this term. So I can use this method, in fact, and finally I can write something like this, this one, and plus 1.5 times here it's minus 0.5 over 2 times minus 0.009, and the other one is 1.5 times minus 0, no, plus 0, and this one also will be plus, times minus 0 over 3 factorial times minus 0.005, and finally I will get plus 1.5 times half times minus half times minus 1.5 over 4 factorial times minus 0.005, and if you compute all of these numbers you can get to 0.295, and this is the value of f of 0.3 that will be equal to P of S. This is one example when we want to compute the value of a function in one specific point. But if you don't have any specific point, and you have just a table and you want to compute a interpolating polynomial, what can we do in this case? Let me give you another example. Okay, suppose that we have a nodal points like this. Let me write the problem. Find the interpolating polynomial for following nodal points. Okay. What are the nodal points? Let me write the nodal points here. This nodal point, xi and fi. 1, 2, 2, 5, 3, 10, 4, 17. Okay, for the solution, look at the nodal points to xi. There is 1, 2, 3, 4. So they are equidistant. So I can use the new method that I told you. So let me xi here and here. 1, 2, 3, 4, 2, 5, 10, 17. Okay, now let me write delta fi. This one, 5 minus 2 will be 3, 10 minus 5 will be 5, and this one will be 7. Okay, you can see that the computation is much easier. 5 minus 2, 2, 7 minus 5, 2, and if I compute delta 3fi, this will be 2 minus 2 will be 0. And now I have every material that I need. I have to use this one. Let me mark it by something else. This one, this one, this one, and this one to compute the interpolating polynomial. But first of all, I have to compute P of S, and after that I have to change the variable from S to X. So let me write P of S to form sum k equal to 0 to 3 combination k of S delta k f of x 0. Okay, if I extend this one, put k equal to 0 and keep s, so it will be 0 of s delta 0 f of x0, and x0 is in fact 1, I think. Yeah, it will be 1. Let me check something first. Yeah, let me write x0, no difference, plus s1 of s delta f of x0 plus 2 of s delta 2f of x0, and finally plus 3 of s delta 3f of x0. Okay, now I have these terms. Delta 0 of f of x0 is 2. Okay, and this one will be the combination s of s is, it will be 1 in fact. Yeah, it's correct. Yeah, it will be 1. So here finally I get 2 times, this will be 2. Let me show you. This will be 3, this will be 2, and this will be 0. Okay, so I will get 2 times this one, and this one I know is equal to 1. So finally I get 2 from the first term. And here s1 of s is s, just s. Okay, so 3s appear here, and here I have plus 2, and here s2 of s is s times s minus 1. Okay, so it will be 2 s times s minus 1, and if you simplify this one is 2 over 2 factorial. 2 factorial with 2 will cancel, and finally you get s squared minus s plus 3s is plus 2s plus 2. This is the polynomial with s as a variable, but we want the polynomial with x as a variable. Okay, now I have to do some more computation. To this end, it's just enough I do some change in the variable. Look at here, we had x is equal to x0 plus sh. Okay, so it will be 1 plus s, and h is 1, so 1 plus s. So here I can get s equal to x minus 1. Okay, so here this is p of s. So p of x equal to so let me write something else here. For example, here consider p of s equal to p of x minus 1. Okay, p of x minus 1, and it will be 2 plus 2 times x minus 1 plus x minus 1 squared, and here if you compute you can get p of x equal to, if you simplify this one, x squared plus 1, and this is the polynomial of degree 2 that interpolate these nodal points. And this is in fact forward difference technique for computing the interpolating polynomial. We have something exactly the same, namely backward difference, that I ignore it and I don't mention it, just maybe as a formula, but the general form and the computation are exactly same as everything that I told you here. Just please follow my channel and subscribe my channel, and do not download my videos in my channel and watch online, and introduce my channel to your friends. Thank you, and wait for the next lecture.